Hey everyone, so I wanted to quickly go over what you did on Friday and then we'll discuss how to do scale factor. So on Friday you were asked to identify similar shapes and write rules for how to determine if shapes are similar or not. And you had this assignment that you see here on my screen. And if we look at shapes in number 1, we can see that they are both triangles. They both appear to have the same angles throughout, and they look to be exactly the same. It's just one of them is smaller than the other. So I would say these two shapes are similar. Now, if I look at shape pair 3, they look similar, except the smaller of the two is slanted a little more to the right, which tells me the angles are different. So I would say these two are not similar. If I look at my circles, well, as long as they're perfect circles, they're always going to be similar. So those ones are good. These two I would say are not similar because they have different number of sides. This one has 5, it's a pentagon. This one has 6, it's a hexagon. So those are not similar. If I look at number 4, well, they're both triangles, so they have the same number of sides. This angle is definitely the same, okay? But they are the exact same height, and the other two sides are shorter. So while they are the same shape, I wouldn't say they're necessarily similar. So we could say that two shapes are similar if they look alike, but one is smaller or bigger than the other one is. Now, if I look at this side, I can see that we have angle measurements and we have side lengths. So if I look at pair number 1, I can see that the angle measurements are exactly the same. Okay, that tells me they are most likely similar as I thought before. And if I look at the lengths of the sides, so like 180, 90, 140, 70, 150, they're not the same, but each side has been divided by 2. So 180 divided by 2 is 90. 140 divided by 2 is 70. 100 divided by 2 is 50. So the side lengths are proportional to one another. If I look at 3, I can see I was right. They have different angle measurements. So I would say, yes, those are definitely not similar. 4, yep, I was right. These are the same, but the other two angles are not alike. So again, I would say that's not similar. Number 6, I can see that my side lengths appear to be proportional and my angle measurements are the same. So I would say number 6 is also similar. So we can update the rule to say that similar shapes look the same but are different sizes, have the same angle measurements, and have side lengths that are proportional to one another. This is different from congruent, where congruent shapes are going to be exact copies of one another, meaning the angles are the same, the sizes are the same, the side lengths are exactly the same. So congruent means exact, similar means the same but different sizes. Okay, so that's one thing we want to look for when we're doing similar shapes. Now let's take a look at what we are doing today. We are going to start looking at scale factor. So a scale is a ratio that compares two measures. We have triangle A. It is equilateral and all of its sides are the same length. Each side has a length of 4 units. So this is 4, this is 4, and this is 4. And it's asking us to draw a new triangle B, which has side lengths that are 50% the length of triangle A. So to figure that out, I'm going to take the length of triangle A and I'm going to multiply it by 0.5 because that's 50% as a decimal, and I get 2. So triangle B is going to have side lengths of 2. And this would be my triangle B. So what we just did was scale down triangle A to make triangle B. And if I wanted to write a ratio comparing triangle B to A, I would say B over A, because it asks to do a fraction. The side length of B is 2. The side length of A is 4. And I can simplify it down and say this is 1/2, because triangle B is 1/2 the size of triangle A. This number right here is what we call our scale factor. And a scale factor is the number you use to reduce or enlarge a figure, okay? And we can say it as 1 to 2, we can say it as 1/2 or 50%. Now let's say we were asked to find a new image, triangle C, and triangle C had side lengths that were 150% that of triangle B. So now we're looking at 2 and 150% of that. So I'm going to say 2 times 150% as a decimal is 1.5, and figure out what that number is, and that is tell me how long each side needs to be. So 2 times 1.5 is 3. So I'm going to draw triangle C now. And here is C, and each side is 3. And again, I'm going to write the ratio. So C to B would be 3 to 2. So my scale factor from B to C is 3/2. One thing to keep in mind when you are doing scale factor, if your scale is greater than 1, that means we are enlarging the figure. Okay, we're going to make it bigger if it is greater than 1. If your scale factor is less than 1, that means we are making that figure smaller. So if we look at our 3 examples up here, our scale factor from A to B is 1/2, and we can see that B is a smaller copy of A. From B to C, our scale factor is 3/2 or 1.5, and triangle C is bigger than triangle B. We went up in size, okay? So greater than 1, we're going to increase the size. Less than 1, we're going to decrease the size. As you're working on today's assignments, please let me know if you have any questions about how to do scale.